a paradigm shift, or it will be as disruptive as the reuse and recovery paradigm which is happening currently in the launch vehicle area. And today we are having with us three eminent speakers, and all of them are veterans in the field of on-orbit servicing. And we are having Thomas Carroll, Manager, Business Development and Space Logistics. And then we are having Mr. Sakthikumar. He is the founder and CEO of OrbitAID Aerospace Pvt Ltd. And Navin Gopal, Vice President of Strategy and Business Analysis, Astroscale. First, we will have a keynote address from Mr. Thomas Carroll. Basically, his company, Space Logistics, is working on the on-orbit servicing area. And this is the first and only company to perform an on-orbit servicing for the commercial geosatellites successfully. And it was carried out in 2020. The vehicle was called MEV-1. And this technology has won many awards. For example, Viasat has named it as the Satellite Technology of the Year 2020. And then Popular Science has awarded it as the best of what is new in 2020. And this technology has already won the Aviation Week's Laureates Award in 2020. So I think it will be very interesting to hear Mr. Thomas Carroll. And I just hand over the mic to him. And sir, the stage is yours for another 15 to 20 minutes. You can present it. Then I think we'll have a panel discussion followed by a panel discussion. Okay.
Thank you so much. Thank you. Thank you. One of the things I wanted to ask before I start, let me go back up, because we all get lost in acronyms. I'm actually using my PC, so there's no excuse for it not to work for me. I want to ask, just a raise of hands, who here is from ISRO? From the, more from the government side or from the commercial satellite market? Are there commercial satellite operators here in the room? So I just want to be able to adjust what I'm discussing to who's in the market. Who's from universities, students? Great. How about new entrepreneurs trying to get into the satellite OSAM marketplace or something similar to that? Great. Okay, so let me adjust this presentation. One, I don't like acronyms. We all use acronyms and then we forget about what the acronym was about. So I don't like saying OSAM because it's an old acronym and it's evolving. On-orbit servicing, assembly, and manufacturing. We started tackling OSAM at Northrop Grumman almost more than 10 years ago. How could we recycle satellites that were not designed to be recycled? You can't refuel a satellite. Today, there's no satellites up there that are designed to receive fuel in space. None of have like on our cars, we have either a charging port or a refueling port that you can pull up to a petrol station and get diesel fuel or gasoline, or now getting charged cars. Satellites don't have that up there today. We need satellites to have that in the future for us to really have a sustainable marketplace in the industry. Today we don't have that. What we did was we challenged ourselves how to provide life extension of a satellite when it wasn't designed to receive fuel. Some were looking at surgery, cutting things off and putting new fueling caps on things. We decided we didn't want to damage any spacecraft or take any risk on a spacecraft. So we came up with a way to attach to the LAE nozzle, which was what was used to get them in from GTO to GSO orbit, which is a very stabilized part of the spacecraft. It's at the center. It has, everything is centered around that LAE nozzle for efficient thrust of the engines. We decided to use that as an attachment, and that's basically how we started this. What we looked at OSAM is how could we build a sustainable business? How could we generate revenue that could afford us to do the luxury things of collecting debris? Future things, assembly and manufacturing on orbit really has not come to an economic business yet of looking for it. And I think it's going to be delayed with the advent of Blue Origin's New Glenn, is going to have a 7-meter diameter payload fairing. And everybody's reading about Starship from SpaceX has a 9-meter payload fairing. When we were looking at 4-meter payload fairings and 5 meters, there was limitations to physical size we can put into space. That was what everybody was looking at, assembly in space. It still can happen. I think that one of the things I'm going to challenge, and I've been challenging customers around the world, is upgradable satellites, is what's more important than OSAM. There's nothing in here about upgrading. If you look at the satellites that were launched from 2000 to 2010, how many people know what size processor, what Intel processor is in there? Most of them are running 8088s, single line processing chips in their computers on there. They have 20 megabit hard drives. Can anybody think of anybody what's a 20 megabit laptop hard drive? It wouldn't last you but a couple seconds by the time you turned it on. But yet, that's what we have on our spacecraft up there that were launched pre-2010. The electronics work great. It's just they're running out of fuel for station keeping. So we've come up with a way to extend the life by adding propulsion systems onto it. The next generation is looking at how to upgrade satellites. If you take this space station, sorry, you don't understand how passionate I am about this. So I've been in the satellite industry since 1966. So I started in the Defense Department. My father was at Stratcom for the US government, and I first learned about satellites in the 60s when I was only 7 years old, and I helped my father do calculations manually on how to build 100-meter Earth stations and how to get them stable in sandy soils and things like that in the South Pacific. So I've been in satellite business since 1966. I heard Intelsat talk about their 60 years. I've been in this business that long also. I'm very passionate about the satellite industry. I've been working for satellite operators, launchers, both American and Russian. I've left a lot of debris up there. I'd like to go collect that debris and get it out of space. Now I'm at the forefront of trying to establish a new economy on how to use sustainability, but let's just talk about recycling satellites and upgrading satellites in the future. And I would challenge ISRO, if you want to be something, you're making leaps and bounds in your accomplishments, rather than being fourth, there's a chance for you to be first in upgradable satellites in space. I'm challenging the commercial marketplace to put it in their RFPs, to ask for upgradable CPUs, upgradable memories, upgradable batteries. Just changing out batteries on a satellite is important to satellite operators. If you've had a satellite up there for 10 years, 12 years, you know your battery recharging is not working so well. Your solar arrays are delaminating. Why not have changeable out satellite, change the solar arrays? We've been doing that on the ISS space station for years. I think it's on its 3rd generation of solar arrays. We change out the computers on board. Why? We have astronauts on the space station that can physically do that for us. In 3 years, we're going to have a robot on space that can do that for you. Our robot that we've designed, I'm going to show you, on the left here I'm showing you is actual footage from when we docked our first mission extension vehicle, MEV, that acronym. That was basically a Geostar commercial satellite that we took the communication payload off and we put on the similar docking mechanisms adapted from what we did for Cygnus to do commercial resupply to the ISS space station. So everything we learned about approaching and docking with the ISS space station, we used that technology and that design and our experience to dock to commercial satellites with MEV, Mission Extension Vehicle. And on the left, you see kind of a sped up process of it. The video here only represents the last 12 hours of docking. You don't come up on a satellite quickly. Even at geo orbit, there are space waves that you can create, and you can cause perturbation of the spacecraft by approaching it. So it's not a perfect vacuum up there like we're all taught in our textbooks from when we were in grade school, that space is a vacuum. There are still space waves up there, and you can cause perturbations as you approach a spacecraft. So you have to come in nice and slow to it. On the right side is our next generation, which is the mission robotic vehicle. There you can see, I'm just going to see if I can stop it. Oh, I can't. The mission robotic vehicle is this device here that has 2 robotic arms. They're fully redundant arms. We only need one of them for our first, what we're going to be doing of docking the next generation of mission extension vehicle. It's called a mission extension pod that is basically its own augmented propulsion system that we add to a spacecraft, and it can add 6-10 years of life depending on the dry mass of the spacecraft. That we moved all of the LiDAR and the cameras and everything and the docking software that needed for our pod operations. Again, there's an acronym. Rendezvous, operations and proximity, and docking. For all those operations with the mission robotic vehicle, we have all the sensors on the robotic vehicle and not on the actual device that we dock to the commercial spacecraft. So, and today I'm talking just commercial spacecraft. There are other versions of the mission extension pod that we'll unveil in the future. And I will apologize for Northrop Grumman as a whole. We're a very quiet, reserved company. We really haven't been out talking much about what we've been doing. The industry's finding out what we've been doing, and we're becoming more public and going to share it more to it. We are trying to build a commercial business that will be a basis for us generating revenues and profits for us that can do things of doing debris recovery. If we can get the lawyers out of space and we can come up with a viable way that we can collect debris without having to identify the launching nation of that debris. So technically, even a small 10-centimeter piece of carbon fiber, we have to identify which spacecraft that came from and which launching nation is responsible for it, and get their permission to collect that piece of debris to destroy it or discard it somewhere farther into space. Thank you, lawyers. I know that there's a reason to protect us. Of course, we don't want to capture an entire spacecraft in orbit and try to identify what's on that spacecraft. So that's what they're trying to protect, is the technology. But some things have to be done in moderation, of course. So if we're going to get rid of debris in space, we have to have something that allows us to collect that debris. And then we can always discuss the physics of it, because none of it's really designed to be captured, and it, of course, is tumbling and at velocities that could rip a robotic arm off of something. So you have to be careful of what is that piece of debris doing. So, sorry, I'm going off on other things. I'm very passionate about cleaning up space. I really agree that we need to do this. My father's not with me anymore, but I remember from the late 60s, the plan was all these geosatellites were supposed to have enough fuel to deorbit GeoOrc and send them off in a trajectory towards the sun for them to be then destroyed when they hit the sun. You only have to get it close to the sun. The gravitational force will get you the rest of the way to the sun. And that was supposed to destroy these satellites rather than sitting in graveyard orbits. So somewhere around, probably lawyers, I know lawyers and sales reps, we all get along so well. But at some point in time, it changed that we're going to put them just in this graveyard orbit. Now we've created this, and now we've got to clean it up. Just like all the debris along our highways, we've got to get this debris cleaned up in space. And so that's what we hope to be able to bring, is the economics for this to develop, that we can do this. And I do challenge everybody to look at upgradable satellites in the future. It's going to be a key to recycling for us, is how to upgrade spacecraft. We've designed a robot that's not like what you've seen in the movies. I mean, all the robots in the movies are designed to be humanoid, so they're not going to frighten us. We designed a robot that looks like satellites, so they're not afraid when we come up to them. It'll look like another satellite coming up to them to do stuff. So we've technically got a robot in space that looks more like a satellite, so it shouldn't be so frightened when we come up to it to do upgrades and all that. Just like we want robots here on the planet to look humanoid for us to interact. You don't want to interact with this spacecraft, this robot in space. So If you're coming to Washington, D.C., I highly recommend you contacting me. I'll try to give you a tour of our robotic lab. We're just by Dulles Airport, our factory. Our robotic vehicle is under construction. The robotic arms have been installed on the robotic module. It was so exciting last year when they finally put the tape on the floor. Anybody that knows about satellite manufacturing, when they actually put the sign up and put tape on the floor at the factory, you know your spacecraft has finally got floor space to be assembled. Ours is under construction at our facility at Dulles, and our mission extension pods, the first 3 of those are under construction out in Gilbert, Arizona. So I want to be respectful for time. You guys can ask tons of questions to me, all you'd like. But we are Space Logistics, and we're now approaching 6 years of on-orbit servicing for Intelsat. That we've been flying both attitude control and station keeping for 2 of their spacecraft now for almost 6 years of on-orbit service. And we're going to do, we announced they bought 2 pods for 2 satellites. They haven't announced publicly which one we're going to announce them to. And we're putting one on a satellite for Optus. It is the way to recycle satellites rather than send them up into the graveyard orbit, is extend their fuel life. So thank you very much. Should I ask them any questions? Okay, you're the boss. Let me move aside. Okay, thank you.
Hello. Okay. Yeah, I think we had. I have introduced Thomas Carroll. I request Sakthikumar to introduce himself actually.
Thank you. I'm Sakthikumar, founder and CEO of OrbitAID Aerospace. I was worked at Indians of Science past 8.5 years, 9 years. So when I'm basically a researcher. I do lots of, my background is space propulsion, all those things. I started my research 2011, then I came to know that before that what happened to the satellite, Then I realized that the satellite is one-time usable. So 2012 or 2013 we recognized, so there is a potential opportunities for research as well as business. So why don't we extend the life of the satellites? How do we extend the life of the satellites? So existing satellites, so it is not accessible for that fuel walls and all those things. Maybe extension part can be attached, but it will require lots of investment. So, 2015 we came up that idea and we patented and all those things for the docking and the refueling mechanisms. Then realized that that time that the space sector is not open for that in India. So we stopped it and again we resumed it 2021. 2021 we incorporated Bangalore and so mainly we were working on that on-orbit refueling for this satellite life extension and plans to build a fuel station in space at the multi-depot extension pod. It is like he mentioned, Thomas has covered everything. He covered fuels and battery recharge, all those things. So we are also working on the payload upgradations with the robotics arms as well as multiple, so different customers have different propellant they'll use. So multi-depot extension pod will be used for that our space station. So that will give that more opportunity to more fuel refueling for the other customers as well. And coming to this payload upgradation, so we have that come up with payload upgradation docking mechanism as well. This can be used for accessing that AOCS and battery booster, battery replacement as well, and can be do that payload upgradation. So maybe small payloads can be upgraded. So we are working with, now we are done maybe for 10 kgs, and later we'll go for payload upgradation measure maybe lots of it. Other than we are working on that on-orbit simulator facility. So with 2 robotics arms, it's exactly mimicking that microgravity. So that is we are working on it. So it is maybe next year, end of 2024, we are planning for technology demonstrator. So where we are launching, it's the first time. So we are launching merger satellite. It's we patented. We dock the satellites and send it, and do the refueling and go for close proximity, and then do lots of activities. So the announcement will come soon. So that's about OrbitAID. Thank you.
Okay, thank you, Shakti. I'll introduce myself. Joji Chaman, and I am Deputy Director at ISRO Inertial Systems Unit. I'm taking care of the spacecraft activities, and we are doing a lot of space robotics currently. You might have heard of Yomitra, and then we are also into this space debris management and refueling technology also you would like to try. Okay, so I have a few questions. I have prepared it, and the first question is I wanted to ask Mr. Thomas. Currently, sir, there are two schools of thought. Like one is low-cost constellations, where our satellite life is only 3 to 5 years. And another school of thought is like long-life, high-throughput satellites, which is costly satellites, which may be currently 12 to 15 years. So how the market is going to progress, nobody can predict currently. So how this technology, if it is going to be constellations with the cheaper satellites, how this technology of on-orbit servicing is going to be viable? Can you just...
Very good question. 1, 2, 3, testing 1, 2. Very good question. First I'll say is, if you look at the history of all LEO constellations, all of them went bankrupt. Not until they were recapitalized were they actually be able to turn themselves into profits. The investment to get into LEO constellations is a tremendous investment. It's much greater if you look at the total investment of a LEO constellation compared to 3 or 4 space satellites. You'll find that the LEO constellation is much more expensive to build and operate. You can't just focus on one spacecraft that maybe costs $1 million or $2 million to build versus what's a geosatellite now today? Commercially, can't get one for less than $200 million. So by the time you get into orbit, it's a $300 million asset. But that one geosatellite has the throughput capability for hundreds of LEO constellations. So it's a hard thing to measure. I still think that putting spacecraft up there that are only going to last 3 to 5 years is just as bad as the difference of using plastic versus glass for water bottles and using one-time use of plastic bottles. I applaud India having water bottles with real glass that can be recycled much easier than plastic. So it's a challenging one, but I haven't seen a LEO constellation yet that hasn't gone bankrupt. And I hope that the ones that are going up now will not, but we'll see what the future is.
Yeah. Okay, Mr. Sakti, you are a pioneer in this field of, in India at least, in the field of this on-orbit servicing. So what are the critical technologies currently you are working on for this activity? Can you just highlight 1 or 2?
Okay, so main thing is, so to access the refueling mechanisms, refueling port, so that we developed that combined refueling and docking mechanism. So that is, we are working on it. So that is, there's less than, that it has a passive and active interfaces. Passive interfaces is less than 350 grams. So it is compared with, again, it is compared with FDV. And other one is, we are working on payload upgradations, as I mentioned earlier. That is one thing. And the payload upgradation also, it is required. So I mean, that upcoming satellite is required. They have to change that. They have to adopt that interfaces. Otherwise, in future we can't do that any payload upgradation. So that is very much is needed. So that also we are working on it.
Yeah. Okay. Thank you. Mr. Thomas, actually we are having 2 kinds of satellites, we can classify them, like cooperative satellites and non-cooperative satellite when it comes to servicing. Currently all our satellites in orbit, they are non-cooperative in the sense they are not designed to be serviced. In future, do you envisage that whatever satellites we are going to make, they need to be made so that they are cooperative, so that as you have put it, it is more like upgrading the satellite, not. So what is your view on that?
I agree 100%. We need satellites that are upgradable in the future. Today they're not. That's what I was talking in my presentation. Our mission robotic vehicle, we hope to have a standard passive refueling port on our mission robotic vehicle when we launch it. We are waiting for confers and all of the standardization organizations to come up with what is the design of that passive fueling port. We are designing one also. We're all designing these passive fueling port, but we need a standard one. And what the standard ends up being defined, we hope it's in time that we can put it on our mission robotic vehicle, because we hope to be able to go to OrbFab and get fuel on space. We've invested in OrbFab itself, which plans to be a commercial on-orbit depot. But they're only going to be the depot in space. We're planning to also have pods that'll be refueling pods that we can go to the OrbFab, get fuel, and then bring it to your spacecraft. Because you can't take a spacecraft offline for 2 weeks and move it 60 degrees in longitude, get fuel and bring it back. I mean, you'd lose all your customers in that time period. Maybe military satellites can afford it if they have redundant spacecraft on orbit, but commercial satellite operators can't afford to go off air for 30 or 60 days to get refueled. So we're going to be that last mile in delivering fuel also in the future as part of our roadmap also.
Okay, thank you. Mr. Sakthi, yesterday when you were in the other panel and you were just discussing like using ISRO facilities and expertise in a particular field of refueling. No? So have you approached anybody, or what is your experience in that area? So how we can help you in doing this?
Sorry. We approached LPSC, honestly, and for that space qualification test as well as the propellant transfer test. So that is we approached LPSC and through InSpace. We got a response immediately, and we are working on that. We done some small tests that with hydrogen, but we are going for multiple propellants and high pressure and other space qualification tests as well. What I can say that whatever through that InSpace we are going for that, especially for space qualification, or if you want to do launches, it will be good. So you can get it whatever you want. That's all.
Yeah, okay, so next question. In one of your slides, Thomas, I have seen that you are working with the DARPA agency, right? So that is a defense analysis wing in US. So how is your collaboration with the DARPA? How they are helping you in this area?
DARPA was instrumental in our business. They've been working on robotic arms for space over the past 15 years and using US taxpayer dollars. Am I not online? I can speak louder and just we can talk without a microphone.
You can use my mic, I think it is working.
It's working, yes sir, thank you. So DARPA has been working on robotic arm development for almost 15 years. A different contractor was going to put it on a spacecraft and terminated their agreement with DARPA, and we picked up the contract. As part of the DARPA contract, they're providing the robotic arms on our mission robotic vehicle. They're being installed right now on the robotic module at their facility, and it'll be back to our campus sometime this fall. Very instrumental in giving us the leap of technology to robotic arms designed to operate in space. Probably a little bit stronger than we need for commercial operations. And we will do some demonstrations with the robotic arms that will meet the objectives of DARPA that they needed as for the development of the robotic arms. We will do demonstrations to meet their objectives with this in between when we're doing commercial operations.
Okay, thank you. Next question is to Shakti. So, robotics forms a major part of this on-orbit servicing. So, without robotics, I think it will not be, because currently all the servicing whatever is currently happen. For example, if you see the servicing of Hubble Space Telescope, or maybe the Solar Maximum Satellite, in all these areas, human was in loop. With the human only, all this we could achieve. But what we expect is in future it should be made autonomous so that the risk and cost involved in this servicing can be reduced. So robotics forms a major part of this servicing. So Shakti, what is your view on that? How you are planning any robotic activity you are planning in your company, or how is your?
Yes, absolutely, yeah. Without robotic arms, you can't go for what is it, on-orbit servicing. So otherwise, you'll damage your client satellites as well. But if you have that robotic arms with 60 degree of freedom or 7 degree of freedom, using that, you can do lots of activities. Not only that, refueling, so payload upgradation. Anyway, the payload upgradation is very much is needed. Only with you can do only possible with robotic arms. That is one thing. And other one, so other activities, assembly and maybe that inspection. Inspection also it is coming under that robotic arms. So without robotic arms, you can't do it anything. But what we are developing now, we have done that robotic arms with the docking and with using that AI. So creating that trajectory and finding out, do that other assembly and payload upgradations, all those things we done. But we still wanted to improve more, and maybe in space qualified things, robotic arms, we want to work more and more. Anyway, it's investment is it's major part here.
Yeah. Just want to add one thing to that, if you don't mind. Thank you. For robotic arms, what's important is the tooling on the end of the robotic arm. And ours is designed so that we can change out the tooling. And we've also put on our mission extension pods basically a port so that we can stow a new tool for our robot. Our robot can handle eight different tools on its tool belt so that it can interchange the hands based on what assignment it has, what job it's going to do. But I want to officially offer to ISRO that you can use our robot in space, and you can even customize your own tooling for some application you come up with, and we can get that tooling up to space and onto the robotic arms to perform something for ISRO. If you come up with some idea that you would like to do in-orbit spacing, you can build your own robot, or you can also use ours. So I definitely will extend Space Logistics Robotic Arm to be able to service ISRO in the future. And whatever specialty tooling, we'll give you the physical and electrical interfaces, and you can build your own tooling for it, and it can go up on our mission extension pods. So
yeah,
we can do that easily.
Yeah, okay, next question. I think it is to you only. So yeah, now see, space market is going to be global only, because we cannot work for one single country and you will not be able to make profit. So definitely it has to be global. So in that scenario, standardization becomes a major challenge, because especially if you want to replace something, these adapters or interfaces should be standardized. Otherwise, one design will not be able to apply in another country's spacecrafts. No? So how do you see this scenario actually without standardization? How you are currently trying to manage it, and in future whether you'll be going for a standardized adapters, so that at least in ISS I know they are having standardized adapters. At least 5 countries are having the similar interface, so that we are able to use that. Similar thing, anything we are planning for the future? We need to plan for the future.
Well, just make sure that I'm online. So we looked at all of the LAE nozzles that were installed on spacecraft from the mid-90s through 2015. And there was 11 different LAE nozzles that were designed and deployed. I'll have to say I don't know if we've researched all of the ISRO spacecraft and the LAE nozzles that were used, but predominantly because of physics, they're almost all designed about the same way. It's just a matter of the diameter of the opening of the LAE nozzle and the length of the nozzle. But we have 11 different ones in my robotic lab at Dulles, and we've tested with all of them that are non-destructive method of attaching to the LAE nozzle. We can dock and undock to it without damaging the LAE nozzle. We've tested with 11 different models of LAE nozzles that we know of for commercial satellites around the world. So we've tried to have the foresight of all the potential spacecraft that we can service. The real challenge is when we get to electric propulsion. And refueling and xenon, that's a different answer than we have our answers for that we're working on also.
Yeah, okay. I think we are having 15 minutes left, so I hope audience are having questions. So I'll just open this session for audience now. If we are not having enough questions, then we'll come back, and once again, I have few questions, so we'll come back to that.
Yes, I'll add
yeah.
for that standardization.
Yeah, please. Yeah, go ahead.
Sorry.
Yeah.
Sorry, Anthem. Yes, that standardization, that whatever Joji sir mentioned is for different satellite, we can use different interfaces. That passive interfaces, active interfaces has to be standardization. That standardization, we are working on it, and along with the Confess, and I'm also part of that AAA committee, so I also submitted that some comments about the fuel transfer thing. So that can be used for storable liquid, but Thomas said it's a question for xenon electric propulsion. So that is very much, maybe it is a little bit research is involved, and that more standardization part has to be involved, and it will take a little bit time. But this, whatever that interfaces can be used for xenon as well, but need to have some higher pressure as well, but we need to work more and more.
Okay, thank you. I think audience, we'll take questions from the audience. Yeah, okay. Somebody is there to hand over this mic.
Okay,
Yeah.
I can hear you.
Yeah, we can hear you. Okay. Yeah. Yeah.
Thank you very much. I'm a professor there. I also have a startup called Inspacity, which is directly in the area of in-orbit servicing at the beginning, but in LEO. And very, very inspirational work from both space logistics as well as from Shakti's company, OrbitAID. So I have several questions, but looking at the, I'll just stick to the most important one. So I think Mr. Carroll talked about us being able to now upgrade components in space, correct? And when we talk about geostationary satellites, especially, where radiation is a bigger challenge, how do you construct it so that you are able to access the components of the satellite inside, right? You imagine that you have the radiation shielding, on top of it you have the thermal shielding. You would need to get through all of those, and then, maybe it's a simple question, but yeah.
Each has its own challenges, of course. So for a CPU, it can be just as simple as a USB port, just plugging in a memory stick. For thinking of adding a terabyte of memory could expand the software that satellite has. So it can be just as simple as a data port plug-in. Batteries, everything can be designed. There's great engineers in this room that could all figure out how to have a interchangeable battery. We change batteries on cars. I don't want to do 2 cables and all that stuff like on a car, but it can be designed. Just like we can change batteries in flashlights for many years, we can change batteries on a spacecraft. It just needs to be part of the RFP. Those people that are buying the spacecraft have to make the manufacturers design it. And until that happens, it's not going to happen.
So let me suggest, a segue into that answer. That would you suggest that some components be assembled in space? Because once you make something that is serviceable, you need to open some kind of a latch in order to, the latching needs to be there for it to withstand the loads when it's launched, right? And do you want it to be assembled in space in that case in order to, take away that concept of latching? Right now, you're able to attach MEP onto another satellite just by, putting a rod through and, opening up a pair of, or a set of tongs inside. Would you say that something similar should be there, right? The memory, the CPU, the batteries are all assembled by your robotic vehicle or by another robotic vehicle in space?
I would leave that to the industry to do this. What I'm having is what we talked about, is my robot is going to be the first astronaut that can move around space and do these work. Today, only astronauts on the space station can actually, or cosmonauts, or whatever the proper term for each FARA nation that goes to the space station. You need humans to actually upgrade the space station. However it's designed, we hope that our robotic vehicle can be that tool, that mechanism that comes and does it for them. That's what's been missing. before doing any assembly on space. If someone wants assembly on space or manufacturing on space, we, Northrop Grumman, are one of the 4 companies that are going to put up a private commercial space station. So that's under development at Northrop Grumman, is building a space station that hopefully will go in some orbit where we'll basically capture debris, grind it up, and use it for component printing using 3D printers on space station. So that's kind of our future vision at Northrop Grumman. As part of Northrop Grumman, I want to say that.
I'll add it to this, the thermal protections. So yeah, it's very difficult to open or cutting or something that thermal is taking, and if you are that while cutting it, if any dust is there, if dust is enter into your payload or your electronics, then gone, everything is gone. But OrbitAID is working on that the thermal multilayer, so zipper multilayer. It is autonomous multilayer. It's so no need to cut it. So if you are operate through that, so earlier you have to cut it, but we have that we have that patented one, just zipper one, autonomous. Just open it and open that wherever that port is accessible. You can dock it and close it. So that kind of things only we are working on. So it's actually you can 100% you can protect your thermal radiation, all those things.
Professor, we hope to be an enabling technology for these things to evolve. It's that simple. By having it.
We'll take the next.
Dr. Joji, I have a question for you. You talked about cooperative satellites. Yes. You know, we are going to launch a huge number of satellites in the coming years. That's why we are sitting here.
Yeah.
So, do you have any data as to how many cooperative satellites do we really have in space right now? Do we have even single? Or in the future, is it going to be planned? Then only this on-orbit thing would be successful or financially viable?
No, I'll answer your question in this way. Actually, ISRO satellite, if you concerned, currently we don't have any cooperative satellites. All are non-cooperative only. But whereas the technology, currently what Thomas was talking about, attaching a module to a available satellite, it is easier to do. Because it is just a propulsion module we can add, or it's a battery, or it's a power cell, we can add it. But whereas if you want to really fill the fuel into the satellite, so then it has to be mostly it should be a cooperative satellite. That's the easier way to do. But recently, Boeing has done an experiment on board where a non-cooperative satellite they have captured autonomously. They have removed cut the wires for that cap. They have removed it and they have filled and shown. So that technology, but it's a very, very complicated technology. But our aim is, what our mandate is, like our chairman, we have discussed this technology. He told, in next 5 years, our satellite should be equipped with an interface, a standardized interface, so that all these satellites will become serviceable. But that we have to start now, because once a satellite is launched, it is planned to be there for 5 years. So if it is incorporated now, only after 5 years we will be able to service. So this is a type. If you want to make them cooperative, today we have to have the interface attached to our current satellite, so that in at least after 5 years we will start servicing them.
So what we can say that now the next satellite from ISRO would be cooperative?
We are planning for that, yes.
Good.
Yes, yes.
Okay, second question is to Mr. Thomas. You are a proponent of space debris cleaning. And it's quite ironical that in the next session, in the adjoining room, we have satellites for SDGs. But satellites itself is a part of the problem, not living sustainable as far as space is concerned. So is there any institutional mechanism, all these spacefaring countries where this can be taken up as a effort all across the world? What is the regulatory mechanism right now? Is somebody responsible for it? Is the agency there, or they just have to left to somebody to just think of it?
Well, it's enabling the technology to be able to capture the debris and remove it. So the ITU registration of all commercial satellites require them to remove debris if the technology is available to them. Today, it's not available to them. So if a satellite was to, say, not be able to get up to the graveyard orbit on its own and became orbital debris at 0 degrees inclination, it's just basically there, and it drifts around the orbit, and everybody knows those drifting spacecraft and avoid it. But under their original ITU license, if the technology is there to remove it to take it up to graveyard orbit, they have to pay for it. They have to expend those monies to remove it from that orbit. So we're that enabling technology that the ITU, which its level of enforcement could be always questioned, but will be that enabling technology to be able to remove that spacecraft from the GeoArc and move it up to the graveyard orbit. Because the technology's not there, the operators are not required to do it. But when that technology is there, then they have to use that technology to basically remove their debris. So, and I was saying earlier, there's a lot of debris up there that it's hard to identify whose debris it is. And so we can't just go around collecting debris in space. There's different orbits of debris. So the most concerning one to the entire planet is the LEO orbits between 400 and 600 kilometers above Earth. That is the most dangerous orbital plane and the one that's most apt to have the most debris right now and has the most active debris. The GeoArc is actually not that bad, and it's very manageable for potential collisions and avoidances of debris in GeoArc. But there is still, anywhere there's debris, it should be removed, of course. And we hope to be that enabling technology that hasn't been there. And we hope that to have it on orbit in late 2025. We're planning to launch in early 2025, and it'll be available to all commercial operators, to everyone starting in late 2025. So.
I have, hello, Thomas, I have one question. Like, there are two types of satellites in the orbit. That whatever like Joji has said also, but my two types are different. One is responsive, another is unresponsive. Like means certain satellites which are launched, which they do not perform due to some reason. They are also orbiting in the orbit. There are another type of satellite which are end of the life satellite. Their life is now almost over. Now we want to extend the life of it. For the end of the life, it is easy to run over and capture it. But something unresponsive satellite, how to service it? That is the one question. Because they may be spinning and they may not be actually stabilized.
All non-responsive ones are tumbling.
Yeah.
They eventually start tumbling.
Yeah.
So that's just
another thing,
nature.
End of the life satellites, is it economic viable to actually extend the life? And what I'm seeing that what that MEV, what you are having it, it's like a satellite only. So the number of missions it can impart in the orbit, it will be limited. It is not coming back to Earth to refuel or to get that supplies again. So whether will it be really economically viable to have this kind of vehicle in the orbit, we having limited only missions possible?
Without giving out the full.
Number of like batteries or number of spares which need to be upgraded in the existing satellite.
Just over the next 5 years, there are more than 400 geosatellites that need servicing.
Yeah.
I'll just simply say over the next 5 years, there's a huge marketplace. It's not a long-term marketplace. The next generation will be those that were launched with electric propulsion.
Yeah, that's
and
right.
extending
Because
those.
technology
But
is
the
changing it.
non-responsive ones are the most dangerous ones up there. And those are the ones that we need to basically approach, use our radar and our LiDAR and our cameras, evaluate it and see if with the robotic arms can we grasp onto it. Can we match the rotation and all of that spacecraft, rotate with it and get in its same tumbling method, attach to it then and slowly slow it back down and then take it up to graveyard orbit. So we've looked at those models. Again, those will be spacecraft by spacecraft, because each one of those, it's dangerous when you grab one, you don't want to then cause more debris by things breaking off of it.
And when you conceptualizing this actually vehicle, are you going for mission specific, like that means a payload specific, like a particular satellite in the orbit, you want to service it, or it is like a generalized?
It's generalized. It's very generalized to address over 400 spacecraft that are in orbit today around the GeoArc. So that's why I was saying 11 different LAE nozzles. We looked at all 11 LAE nozzles on spacecraft to make sure we were compatible with them. So yes, we're going after a identified market today that we hope that will then build us to the next market and the next generation of what's needed in space.
Okay, because lack of time, we'll take one more question. I think there are a lot of questions. I think, okay.
operation it does, and then subsequently it goes for a docking. Okay. So which one will take over the control, whether your MEP or the target spacecraft in the composite?
For an MEP, the spacecraft continues attitude control. We just provide station keeping.
Right.
We supplement we actually turn off your station keeping, we do the station keeping. Well, actually I should clarify, you operate it as your new station keeping device. Because
Okay.
it becomes your property and your operation is the pod. The mission
That's right.
extension vehicle we control.
Okay, okay. The question is to Sakthikumar. Yeah, this is related to, you have done some refueling testing on ground, you have told, right? So how do you simulate that microgravity fuel transfer under the vacuum condition? Do you have any setup with you?
Good question.
Honestly, that we don't have the microgravity setup, but we are working with some Canada space companies. So that is a test bed, actually, air bearing microgravity, that one we are doing. And next one, we are planning for zero-G flight, it's a parabolic flight. So that maybe another 3 to 4 months, we are planning for that, the fuel transfer for microgravity conditions. So it will take so parabolic for multiple parabolic, and maybe it will take 15 seconds for five numbers. So there we can do lots of tests. So, but in-house we don't have, honestly. But we want to build more and more. Yeah.
Do we have time to take 2 more questions? Quick ones. Yeah, please, quick ones. Short questions. Yeah. Please go ahead.
Sir, I would thank you, Dr. Chaman. With your permission, I'd just like to respond to Colonel Manik's question. So, sir, there is an interagency debris coordination committee which has guidelines on these, but space debris is like carbon emissions. We all know it's harmful, but we always feel there's another nation which is responsible for it, and not us, all right? So, and it also, the point is that if one has to follow those guidelines, it adds to cost. So unless all the nations agree to it and start implementing that, no single nation would like to put their industry at a disadvantage by adding costs to that thing. So that IADC is at a stage where it is more voluntary than mandatory. That's just a one.
Okay, one last question. Sorry, yeah.
Come on, nice, tough, real tough question.
When we talk about space debris, I just wanted to know the status of debris at Lagrange points. Do we have that problem as of now there?
For which orbit?
So the Lagrange points, where there is
Lagrangian
stability.
points. I think it,
Lagrange points.
I think may not be, because the number of missions are very limited only so far. I hope it is not a major concern right now. Very limited missions only we have executed, because
Solar energy.
Yes.
Beware of solar energy.
I think our Aditya L1 will be launched maybe somewhere in August or September. So we'll have, that will be our first mission, to be frank, to the Lagrangian 1.
Sir, to Thomas, sir, I have one question. Yeah, you are currently concentrating on the geo orbit for space debris mitigation, but you told that it is more severe in the low Earth orbit. So the debris problem is more severe in the low Earth orbit, and geo is manageable. So, but as we understand, it will be very difficult to traverse multiple geo orbits and low Earth orbits and capture and deorbit the debris. So, is there any specific reason why you concentrate on geo orbit, or do you have any plans to clean up the low Earth orbit also? Is it economically viable?
Excellent question. We focused on the geo marketplace for one thing, high valued assets. $300, $400 million spacecraft are more valuable than $2 and $3 million spacecraft. So commercial entities want to extend the life of a $300 million satellite before they want to extend the life of a $2 million one. If you look at the LEO constellations, I was in the launch business before I've been in this business. And I was actually at a LEO constellation, Orbcom. You won't replace one LEO satellite at a time. You'll wait, you always have on-orbit spares, so you put those spares in and deactivate the one that's trouble and whatever's happened to it. Eventually you get to a point where an orbital plane doesn't have enough spacecraft to provide continuity of communication services. That's when you'll look to launch a replacement plane. but they won't replace it by one spacecraft or two. They'll launch a full another 8 or 12, whatever's in that orbital plane. They're not interested in me going up and extending the life of one LEO satellite or 2 satellites. Most of the LEOs don't have much fuel on them. Orbcom satellites had 0 fuel on them. It was just the initial velocity injected by Pegasus launch vehicle when they went into orbit. That velocity created their orbital integrity. So we don't see an economic marketplace. The geo marketplace there is, we believe there is, and so far we've been able to show to those commercial satellite operators the economic benefits of recycling their satellites at geo. In the LEO marketplace, we will probably do it more for a bigger customer of Northrop Grumman, a more traditional customer of Northrop Grumman, for the US government, and do things in LEO orbits for them. Not probably for commercial, but more for government applications. And let's just say, I don't know it, I'm in the commercial marketplace, so I don't know everything we want to do on the military side, but everything there is at the LEO orbits.
I want to add that thing. LEO is actually the defense agency is looking very much for that. There is a market for defense. And other one is that I agree with Thomas' statement. For the commercial, they wanted to replace the satellite and compare with the refueling. But where the market is in LEO is debris removal people, or debris removal vehicle is there. So it is the debris removal, it is not, they won't launch for only one mission to remove the debris. They will go for multiple debris removal. So there, they need lots of fuel refueling. So that is a market. So that LEO Earth, maybe that debris removal and the defense has a good market is there. That's it. Thank you.
Okay, I think we've had a very fruitful discussion today. I think there may be more questions, so you can approach the panelists separately and then discuss. Thank you very much for the patient listening. I think we have a hall full, so I'm very happy to see that so much of interest is there in this particular field. Thank you very much.
No debris.
Yeah, no debris.
All active
Spacecraft. Okay. Thank you. Thanks.
Very rightly said, sir. If I could, I would give all day for this discussion. A very interactive audience. I extend my heartiest welcome and thanks to all the dignitaries there in the audience and the panel. Now we can head for a half-an-hour tea session break, and you can please discuss there. We will resume back after half an hour at 12 noon, please, for the next session. Thank you so much for the interactive session, please.
Thank you.
Thank you, sir.
Thank you for coming.